All right, guys, 11.1, starting in on chapter 11 here, and it's kind of a break from what we've been doing. Okay, not a lot of solving equations here, a little bit, but not a lot. No square roots, nothing like that. So this is some of it's going to be review, okay, which is great if you did well on it the first time. But if you didn't, then you're going to have to pay attention a little bit more here. So we were talking about measures of center. Measures of center, you might not know them, have them told you or named like that, but measures of center are mean, median, and mode. That's what we're looking at here. So I know that you know some of this stuff, but we still got to talk about it. Talking about mean first, and the mean is another way of saying the average, right? So when we say average, typically that's what we mean by mean. Real quick, it's represented by that symbol right there. We call it X bar. X bar is the mean or the average. So if you ever see that, that's what we're talking about. To find the mean, you got to add up all of them and divide by however many there are. So if our data set is 4, 6, 10, and 14, then we're going to add those up. Let's see, that's 34. And then we would divide by 4. So we would end up with 8.5 for our mean on that one, right? So add them all up, divide by however many there are, and that's the mean of the data set. The median is the middle number, okay? It's the middle number, but it's very important that those numbers are written in numerical order. If it's not written in order, you can't just grab the middle number, okay? You got to put it in order. Typically, I go from least to greatest, and you got to find that middle number. Now, with that middle number, okay, let's say that I've got a bunch of numbers here. Let's say 3, 5, 5, 6, 8, 10, 12. Okay, so if I've got these, there's 1, 2, 3, 4, 5, 6, 7 numbers. So we got to find the middle number. Now what we can't do is we cannot just go back and forth and back and forth and back and forth. Right? We shouldn't do that. Okay, we want the middle number. We shouldn't do that because if there's an even number, that's not going to work out. It works out fine if there's an odd number, but if there's an even, then it's not going to work. Let's take it back. Let's say there's a 15 on there. If I just go back and forth, smallest, greatest, smallest, greatest, smallest, now I'm saying that the median is 8, and that's not true. 8 is not the middle number. Okay, so let's take it back. Instead, what we should do is we got to cross off in pairs, and I can't draw 2 different places at one time here. So there's one pair, and then do another pair, and then do another pair. So if you're left with 2, don't cross off one of them. The median is exactly in between those 2. So the median here would be 7. Okay, so if you're left with 2 numbers, cut exactly in half, that's going to give us our median, exactly in between there, which is 7 for that case. Okay, so be careful on that. The mode is, sometimes people say the most often data entered, MODE. It's the one that occurred the most. Now there could be one mode, no mode, or more than one. So let's say that I've got 1, 2, 3, 4, 5. There's my data set. There is no mode there, right? There is no mode there. But if I put another 5, now the mode is 5. Well, what if I put another 1? Well, now I've got 2 modes. I've got 1 and 5 as my 2 modes. Okay, here's a tricky one. Let's say that we have 1, 1, 2, 2, 3, 3, 4, 4. What's the mode? And there is no mode here. Okay, so the trick about it is if every number occurs the same number of times, there's no mode. Okay, I'll say it again. If every number occurs the same number of times, so if they all happen once, they all happen twice, they all happen 3 times, then there is no mode. If some of them occur more than others, then there is a mode. So let's say that there's my data set. I threw on a 5, just one 5 on there. Well, now my mode would be 1, 2, 3, and 4. all 4 of those would be the mode. Okay, so a little tricky there. Make sure that that you don't get caught on that one. All right, so a lot of what we're going to be asked to do here is we're just going to be asked to find them, right? But then also which measure of center best represents the data, okay? Which one represents the data is when we're looking, which one is the best version of it. So example 1, what I mean by that is if we have a median of 8.7, a median of 8.7, we have a mean of 9.65 and a mode of 8.25, right? We see those 3 numbers. One of those is just not good in terms of representing what this data set actually is. Well, that data set, you look, that 9.65, that mean, there's only one number, one wage that's greater than that, that's bigger than that. All the rest of them are lower. That's not what we would say is a good representation of the data. Okay, the better representation would be the median. Okay, the median, 8.7, that gives us a better idea of what the wages are. Even a mode is probably better than the mean here. The mode being 8.25, we got 3 of them that give that. That's not really in the middle of our data, that's at the lower end of our data, but it's better than this 9.65 that really doesn't do anything for us. So really what this comes down to, which one's going to be best, is when we have an outlier or not. And you see the definition here. An outlier is a data value that is much greater or much less than the other values. Okay, much greater or much less. So we had that with that other one, that's 16.5. Okay, that is an outlier. It's much bigger, much smaller. Now there is a mathematical way, a statistical way to figure out if something is an outlier or not. We are not going to get into that. Okay, we're not getting into that. So don't worry about it. Just if it's a lot bigger or a lot smaller, it's an outlier. So if we take that outlier out, right, and we see it here, if we take that outlier out, our mean is now 8.67. Okay, our mean is now 8.67, which is a whole lot better than the 9 point whatever it was before. Okay, the median is pretty much the same. The mode is the same. So when we look at this, the study tip over here, that's important. That is what I'm trying to point out to you here, is that outliers have the greatest effect on the mean. So if you have an outlier and they ask what's the best representation, choose the median. If there is no outlier, choose the mean. Okay, no outlier is mean. If there is an outlier, the median is the better representation. Okay, that's going to help you answer some questions there. All right, so let's see, what else do we have going on here? That's it for measures of center, but now we have measures of variation. And measures of variation is how spread out the data set is, how far the distribution is. There's 2 measures of variation. The first one is the range. And the range is simply the biggest number minus the smallest number. How spread out is the data from biggest to smallest. Okay, biggest to smallest. That's all you have to do is biggest to smallest, and that'll get you the range. Okay, so I'm sure you're good on that. Just, it's not the first number minus the last number. Like if I'm looking at show B here, I'm not going to do 25 minus 24. I'm going to take the biggest number, which is 48, minus the smallest, which is 19. Okay, if they're not in order, just be careful on that. The other one that we have is standard deviation. There's this whole big process, and I'm not going to teach you how to do standard deviation. I'm not going to ask you to do standard deviation. We used to. We're not going to. It's too much work, and you'll learn how to do it in Algebra 2 or Stats in high school. All you need to know is standard deviation. It's different because it takes into account every single data point. So the range tells you how spread out the data is in terms of the biggest minus the smallest, and that's it. We don't have any clue of what's going on inside of those 2 numbers, whereas standard deviation takes into account every single data point. Okay, so that's the difference, and there will be a question on your homework about that. So standard deviation takes into account every single data point, whereas the range is just the biggest and the smallest. Okay, so that's the big difference there. You don't actually have to find the standard deviation. You don't have to go through this whole process. It really is a pain. Last thing I just want to point out, data transformation. I don't know that this is on the homework, but a lot of times it ends up on the test. So I just want to talk about it real quick here. If you add a number to every point in a data set, when you add the same thing to everything, then all you have to do is add that same amount onto your mean, median, and mode. Okay, that's all you have to do. So if I'm saying that I'm going to take my data set and I'm going to add 4 to everything, well, then I'm going to take 4 and add it to my mean, my median, my mode as well. Let's say, for example, that my mean is 4, my median is 5, and my mode is 3.5 for whatever data set I had. Let's say I'm going to add 4. I'm going to add 4 to all data. So then what that would change, that would mean my new mean, I would just add 4 to it. My new mean would be 8. My new median would be 9. My new mode would be 7.5. Okay, pretty straightforward there. You're just adding the same amount. Notice that the measures of variation are the same. Okay, so that means the range is going to be the same, standard deviation is going to be the same. Now, when we're using multiplication here, if I multiply everything by 4, let's say I multiply everything by 4, okay, that means I'm going to take all of my measures of center and variation, the mean, the median, the mode, the range, the standard deviation, all of it, and I'm going to multiply by that same amount. So if I'm multiplying every data point by 4, my median is going to be 4 times bigger. So my median times 4. My mean is whatever the mean was times 4. The range, whatever the range was, times 4. Everything is by that same amount. Okay, that's what we're looking at with data transformations. Okay, and you can see that in example 5 if you want to read through that. If we're increasing by 50 cents, that means the mean, the median, the mode are going to go up by 50 cents. The range and standard deviation will stay the same. If we are increasing by 10%, that's multiplication. That's multiplying by 0.1. So I'm going to take the mean, median, mode, range, standard deviation. I'm going to multiply each of them by 1.1 because I'm increasing by 10%. So that's 100 plus another 10%. So I'm multiplying all of them by 1.1. So you can look through that on your own and make sure that you got it. So double check, watch the videos on big ideas if you need to. Make sure you're good to go on that stuff.